the volume of a solid. So let's think about then how might we approximate a volume of a solid like this, which is a curve that is rotated about the x-axis to produce a solid like this one. It might be a bit more difficult to think about, but we use the same approach as we use to calculate the area on the curve. It's quite intuitive. So let us have a curve such as this one. And previously we used rectangles, like very small rectangles. We added them all up in order to find an approximation of the area under the curve, which is integration. And if the rectangles were smaller and smaller, then the approximation is more accurate. So in this case, if we rotate the rectangle in an x-axis, what kind of object do we get?
Cylinder.
A cylinder. That's correct. And what is the volume of a cylinder?
Volume.
Pi r squared h. Pi r squared h. So in this case, what does the h represent?
The height.
Height. What is height in this visual?
Y-axis. No, x-axis. Wait,
What
no,
is the
I
value? That's correct.
Yes,
Now,
sir.
what about r? What's the radius of this disc?
Is half.
What is the radius of the disc? Sorry? The y value, exactly. The value of the function at the x points. So let us define wi as an element of the interval between xi to xi. Basically, this means w is going to be a number between these two lines. And let's say the value of the function at w is f wi, as Say just mentioned. So we have a very nice formula for the volume of one sphere. Sorry, cylinder. Yeah. So if we imagine adding up all those cylinders, what do you think is going to happen to the volume of this rotation? If we imagine this quantity gets smaller and smaller, so that the width of this cylinder, the height of the cylinder is very, very, very small, the volume under the curve is going to approach the actual volume of the rotation of the curve. So we can sum it all up. And as this quantity becomes infinitesimally small, this quantity corresponds to this thickness of this area, the height of the cylinder. This quantity we call dx. The function itself is going to approach f of x squared. And an infinite sum of really small quantities is an integral. So the result we have for the volume of a revolution of a curve around the x-axis is given by this formula, where the limits of integration is from a to b. This is given in your data booklet, so you can check.
Yeah, have a quick you got the booklets in front of you. Open it up and take a quick look.
Feel free to interrupt if you have any questions. I don't mind.
Sometimes, intuitively, this is called the disk, just in case if you're wondering. We start to see visually, everybody has their different terminologies, right? Each of these things are called as disks. What page are we looking at?
That's your moment to understand.
Oh, serious.
Right
So,
there.
as
So it's-
Minso said,
so
the
volume.
formula for the
revolution.
volume of a
Okay.
cylinder is pi r squared h.
Pi r.
This is basically the volume of a cylinder, but
Yeah.
many,
Yeah,
many,
I
many
get it.
small cylinders.
Even
This
though we use
can
the
be
word
seen as
cylinder.
h. This is r squared pi. Basically, we have a sum of those small cylinders. So knowing that can help you understand memorize the formula, although you don't have to. Huh? Df, this is the h. You got that? Look. This is the
Yeah,
h.
question about what he answered.
This is the h.
So one of the ways you can think about that is Joseph just mentioned that h can also be seen as the little small change in delta x. Very small little change in delta x. Okay? Now, one of the things that Joseph also mentioned is that if we use the terminology here, cylinder, if we say that's cylinder, then this is known as the height of the cylinder geometrically. Okay? But if we don't say the word cylinder, if we say the word disk, then this is just the change in the disk itself. As just think about a really, really thin disk. Okay, super small little change. That's where the R starts to play a very big role. Okay, go ahead. Good stuff.
So this formula is really handy because we can prove some formulas that we already know. What is this? Volume of a sphere, radius r. Yeah, exactly. Now,
This is cool.
so we can use this formula to prove that formula. So how might we think of a sphere as a revolution of a curve around the x-axis? How might we do that? Any ideas?
Can you remember semicircle equation or circle equation? We don't really learn explicitly. They're known as relation equation. Let's say a radius of, I don't know, 9. What's the equation for the circle?
Y squared plus x squared is
Equals to?
9.
9.
Y equals square root 9 minus x squared would give a
Yeah.
semicircle.
There you go, yeah.
In general, this is the formula for the area of for the graph of the semicircle. So if we draw it out,
In the positive side of the
yeah,
Y.
only the positive side. But
There you go. Here.
so I prepared a graph semicircle. So if you rotate this around the x-axis, you can imagine that it will form a sphere. And we already have the formula for the area of this, the volume of the sphere. So let's plug it in. But before we do that, what are the limits of the integration in what would they be?
-2 and 2.
Yeah. This is minus r. So if it's for a general sphere, the limits of integration would be minus r to r. So if we just plug in the formula, can someone read it out for me? What is the volume going to be?
4/3 pi r.
No, if we were to plug it in.
And R squared minus
You had it, Mitsio. Negative R2. Say it out loud. Look at the, yeah, negative R to R, and then what's your function then? Let me see.
Oh, root r squared minus x squared.
Yeah, yeah,
Oh,
Yeah.
square of that.
yeah. There you go. Yeah, you had it. Yeah.
The squares and the square root cancels. So try that on your own. Just a simple integration problem here. And see if you get 4/3 iris.
Yeah, let's see. Let's see what happens. Let's actually integrate it. Go for it, guys.
Y squared plus x squared is the equation of the circle.
But if you want the full circle, then you have to y equals plus 1 square root.
Oh, yeah,
But then, because you're only considering a semicircle,
Remember, the square root and the square canceled away. So what you see on the board is not just r squared minus x squared. Be mindful, is r a variable or a constant?
constant.
Yeah, so when you integrate, keep that in mind.
Is our test paper 1 and 2 repeats?
It's all together. You're allowed to use a calculator, but as usual, you will. This is just a constant, right? So integral of the constant is, it's going to be r squared. Yeah. Don't forget to draw your boundary. Right? You know, the boundary of a mean limit. Like that we get negative r. Yeah. What do you think is about the integral of x squared?
Everybody done?
Give them a minute or two. This is great proof. Geometry supported by calculus.
I got it.
Separated. That is an integral. And then the second one.
It's exactly the
Calculus can really help us prove formulas about the volumes of such objects. Later we can, as a challenge, you can try how to find the area of the volume of a donut, which I'll show. I'll leave as a challenge for you, but you will have the tools to be able to do that.
이렇게 해서
Watch out for the lines.
이거
도넛은 이거랑 이쪽 한쪽을 y-axis를 돌리는 거야. 그 상태에
이 상태에서
When you put it in here. I think it's just negative, like minus sign.
나왔어.
Yeah.
누나 했어?
Oh, it's not. I don't know.
Okay.
Because there's plus or minus.
Edward, you got it?
Yeah.
So, keep this formula in the back of your head. I mean, it's in the data booklet. But again, as I mentioned, formula is just a restatement of the sum of the small cylinder volumes. As I said, this is h, this is r squared, this is pi. That's merely another symbol for sum. Now, we can rotate it about another axis. We have the y-axis as well. So, how might we approach some problem like this? Well, you also learned how to find the area bounded by the y-axis curve, right? Under the y-axis, this. How did you do it? If you had this x. You can't simply integrate f of x. That won't work. Yeah, dy, right? So you found the inverse function, and then found the y coordinates that corresponded to these two intervals, and then integrated that. Similarly, in volumes, as the formula booklet shows, we can find the volume similarly by finding the inverse function when it's rotated about the y-axis. We simply switch the variables. Okay, A and B are not the same from the previous formula. A and B are the y values, not x values. The limits of integrations are the y values that correspond to the limit to the boundaries that which you're trying to find the volume under. So let's try this problem all together so that we have a better understanding of what it just meant. Would you like to graph that formula first?
Graphing calculator?
No.
Oh, yeah, just try it.
And here, think about the
I made
identity
this a
function. It's ln of x, right?
Yeah.
Ln of x has been transformed. It's an easy transformation. It's x plus e now. So,
Oh. To the left.
right?
Units.
That's right. Yeah. There we go. And think about how that would affect our vertical asymptote.
Oh, okay.
fact, I might use D and C instead of A and D.
These are not the same.
Now, we're integrating with respect to y, so you must find x in terms of y. You can't just put x because it won't work. X is a variable, it's not a constant. So, did you draw the graph? When we draw the graph on the calculator, you don't have to. Looks something like this.
Did they give us boundaries here? Region bounded by the curve and what?
I guess
It need, yeah, it
x
needs,
and y axis.
it needs to explicitly, yeah, bounded by the XY axis.
Answer is infinite.
Now this is good though. Constructing a math question requires extreme attention to detail, so there is no room for a misunderstanding.
First, we must find x. So go ahead and find the inverse function. Inverse function.
왜 인버스를 해?
어?
왜 인버스를 해?
And then y is rotate about the y-axis.
Then you're meant to get x equals to not the inverse.
Yeah. Do what you do, finding a inverse function, but don't switch the variables.
Okay, just rewrite that equation in terms of x.
Yeah.
So x equals inverse 하면은 이렇게 나옵니다.
Find the, rewrite this in terms of x.
Mr. Wood, the formative 2 is calculated aloud, right?
Some parts, yeah. Like you want to show us.
Oh, okay.
The key thing about area and volumes and all that is showing at least one rectangle and one disk, not just drawing it in,
Now we just plug it in the formula.
interpreting it into writing the integral out now. It's the second step. Once you've written out the integrals and whatever, we look at the question of how many points are actually given. If it's only given like 3 x, I think I'm going to use it.
Okay.
If the question shows like, no, it's going to be like 7 points or whatever, I better start still.
Oh, fuck.
You see, like this.
What are the limits of integration? In this case. Yeah, 1, 0. It's the y values, right? Not the x values.
Joseph, may I request that you, if you can draw it in one slice, please? The rotation.
Is E a constant?
Yes. Ooh, sorry. Try to do it on your own and then just check and look at the screen.
Yes, sir. Just 1 second.
This was a problem from Vision Village. Big podcast. We have
Should I just share with you, Mr. Yaman?
Does that apply to like anything? If it's like 1 or 2, like that,
So let's say, where is the 1/2? Edward?
like replacing 2.
Okay, so let's say this is e to the power of x over 2.
Yeah.
So let's say e to the power of x over 2 times 2.
Oh, okay. Yeah.
Because of the derivative.
No, it's
It's
not.
not too far.
Okay, thank you.
Because E is constant here.
Yes.
Whatever it is. Oh, yeah, but no, it's only one.
Yeah. I
Okay,
made
cool
a
way.
reading with Edward that drawing a picture, and what I was suggesting to Joseph, if you want to visually draw in just one slice. For the area, we draw in a rectangle, either vertically or horizontally. For volume, we want to show at least one disk to give ourselves a chance to visualize it, as well as the marker see that you're going in the right method. And then our goal, this is
How do you
mandatory.
integrate this?
You got to write down the integral itself. Now, after that part, we look at the number of
You
points
want
that is
us
given.
to on the,
If they said just
you
evaluate,
get this,
then
right?
of course we use
What
the
happens if
calculator
you-
as Ray just asked. edges. So
Like
you
what
can have
happens if you differentiate them?
But if the question is like 6, 7 points, guess what we're gonna have to do? We have to start saying, show our work.
Yeah.
How's it so far?
It's pretty okay. I get it.
You understand, right?
Yeah. No, because well, like if you like integrate it towards a y-axis, then you have to like switch the
Yeah.
you put like so it's not inverse. It's just
It's not inverse, just switch, solve for the other variable.
yeah, and then the limits also become the y-axis.
Yeah.
Alright, that's good. That's
To the power of
Simple.
n to the
very simple. Very simple.
differentiate term.
Yeah.
It all comes down to your ability to
Do you have anything to say to the camera, Mr. John?
I'm Mr. John. I'm a professional IBDP mathematics teacher.
I see.
I'm teaching about
So then that's
and my student Edward
Louder,
just said
louder.
My student Edward just said that he learned a lot from this class so far.
Yeah, I did. Indeed, I did. I'm just so confused.
What are you thinking? I'm sure you have a question. Let me practice one.
It's not really affecting work.
Practice one more. Yeah, and then you can introduce them.
You get it to like.
I just want these guys to.
Because you know to the work into the.
Well, would you like you just like
Divided by whatever the derivative.
So if you don't anti-chain rule, what I do is I look at the one that's inside the immovable thing, like e to the power of whatever. I look at that and I try differentiating, and if I get that, then that's an anti-chain rule. But then,
너도 그러잖아. What's the answer?
you go ahead. Go ahead.
Yeah, I can't do that by hand. It's 2, 3, 4, 5. If you do that by your hand, you get it. Okay. For additional practice, how do like Greek mathematicians and how do they calculate that?
For the grammar book.
Can we look at the answer one last time, please? Wait. 앞에 why is there a minus at in front of 1/2 b squared?
Hey, Jojo.
Sorry,
Yeah.
that's plus.
That's me.
What's plus?
The front, yeah.
Oh, sorry.
It means you still got it.
Never mind. Fired, bro.
No, you got it wrong.
Huh? So you got. So what do you get when you plug in 1? The ones, right?
Yeah, and then 0.
But then, is this 0?
Oh, because it's fun. So 이거 는 5만 you need the minus.
Wait, plus, because
It is
it's
9.
0, yeah.
That,
So simplify this.
Oh, wait.
Oh, it is plus.
This one's
Yeah,
minus
but
2.
then this pi is brackets.
So minus is correct?
Is this minus?
What?
I forgot to
Hmm?
put brackets.
Oh, yeah, that's right,